Hi, my name is Jijesh. I work at Gojek as a senior principal engineer. Today, I'm going to talk about how the search system evolved in our product. I'm going to talk about the company. Gojek is a on-demand platform in Southeast Asia. Uh, we have wide range of service offering, including transport, GoFood, uh, logistics, etc. We have around we have more than 2.5 million driver partners in our platform, and we operate in major 3 countries in Southeast Asia. So coming to GoFood, GoFood is our food delivery platform in Gojek. We have more than million GoFood merchants in the platform, and we operate in 2 different countries in Southeast Asia. Let's talk about the history of search in GoFood. Like most of the products in Gojek, so GoFood is also started as a monolith and then later splitted into multiple microservices when we hit the scale. Um, so search also become a different microservice. As you can see in the diagram, uh, search service is based on Elasticsearch, and we have other service like content management service, which owns the data like restaurant details and dish details. Those, if there is any change in those data, that will be pushed to a queue, and we have a data ingestion framework that will take those data and push it to Elasticsearch index. And we are keeping 2 different index for uh, restaurant as well as dish. And search system will consume this data and deliver the results back to the user. Primarily, there are 2 functionalities in search service. One is like when a user search for some query, we will take the user location and do a search in certain radius and return back the result to the user. And this result will be sorted in based on distance. So another feature which the search service is providing is serving collections. Collections are nothing but a group of restaurants or dish which meets some certain criteria. For example, in the second screenshot, you can see there is something called bestseller that will give what are the bestseller items in the users area. Similarly, there are other collections like near me restaurants or discounted restaurants and other ones. So during this time, we created a search team as well. This was a very small team where it consists of one product manager and a data scientist and an engineer. So the primary goal of this team is to improve the search conversion from the booking conversion from search. Also, at this point of time, we were like expanding the business. So the service should handle all the scale which is going to come, right, in terms of the active users or the number of orders which is happening in the system. Or also we are expanding to multiple countries, and then other things like supporting of new languages, all those kind of things need to be handled by this team. And obviously, we need to increase the search user experience. So how to improve a system, right? First of all, we have to measure what need to be improved. So we have to be data aware, measure what need to be improved, analyze the data, and do an experiment with the various improvement strategies, right? So there are like certain metrics that are already available, something like booking conversion ratio, which will tell you like certain user actions resulted in a booking, right? Like when a user search for some item and then he booked from the result, that will result in a booking conversion ratio. And there are other customer related metrics like how many searches a customer did before doing an actual booking. Also by other means, like let's say he booked from a collection, or like from a home screen itself from a recommended restaurant, he booked an order, right? So all these things help us to see what what kind of conversion is there, or what kind of effectiveness is there for search. But most of the time, this is not enough to measure the effectiveness of a search system. For example, let's consider two users flow. The first user searched for something and she selected the first result from first restaurant from the result and order food from that. And the second user, he searched for something and went through multiple pages of the result and selected, let's say, from the third page result and ordered food from that. So in both cases, booking conversion ratio will show that it's a success, right? Like both case, a booking happened. But if you measure the effectiveness of search, the second user need to go through multiple search results to find out what he is looking for. So, and so this may not be enough to consider the effectiveness of search. Let's consider another case where the user searched for something and he selected the first restaurant. He went through the dish items available in that restaurant, came back and booked from the second restaurant. In this case also, even though he didn't book from the first restaurant, still that restaurant has some relevance since he selected the restaurant and went through the details of the restaurant. So when we measure these items, like we have to make sure that we are considering the user actions, the positions of the results in the search list and all. There is a standard metrics for handling this one called NDCG that will commonly include each the selection, whatever user actions has been happened in those search results. Also the position of the result for calculating the score. So we have used this metrics to calculate the effectiveness of search, and along with these metrics and user research and also user feedbacks, we come up with certain improvement into the system. So some of the major improvements we have included in the service is first is fuzzy search. Fuzzy search will help us to reduce the spelling errors in the query. This won't work as a full-fledged spell check kind of feature, but at least it's an edit distance-based feature, and that will give some kind of improvement into the search query. The second one is like, if you have noticed in the previous slides, the search result was not doing any filtering, and sometimes people want to narrow down the search result with certain criteria, like let's say they want to do filter the restaurant in certain price range or the rating of the restaurant and all. So we added those filtering feature as well, and to avoid like showing the same kind of restaurants, let's say from the same restaurant from KFC, we group all those brand restaurants together so that we can show other restaurants in the search result itself. And another two features which we added is relevance ranking and personalization. This is kind of like a standard in any of the search service, and we'll look into that how we have implemented it in our service. So relevance ranking. Relevance ranking is something like, instead of sorting the result in a distance based, we need to consider other factors for the result sorting. And these are some of the factors we have considered, like restaurant name and dish names, or the combination of both. Earlier we were like displaying results for restaurant and dish as a separate tabs, and that may not work in most of the cases. And also the users are not going through the second tab, which is the dish tab, from our like data analysis. So, and another factor is like ETA. When someone order food, how long it will take to deliver this food for them, right? So those factors also need to be considered when we are ordering the search result. And Another example is like open close status. This is not just a close or open status as a field in the restaurant, but imagine something like some of the restaurants may having separate operational hours, like they may open for breakfast and then maybe for dinner. And also a restaurant will be having different operational hours in weekdays versus weekends. So we need to consider all these factors while doing the sorting. So turns out that Elasticsearch support this kind of ranking of fields, and we can increase the weightage of fields. And depends on these weightages and all, Elasticsearch will calculate a score of the result according to that, and that score will decide the sorting criteria. As you can see in the code segment, there are for restaurant name will be having more weightage than the restaurant description when searching for something. Also, there are kind of filters, like let's say we are doing a filter of this is the search radius where we need to look the restaurants for that particular user. But let's assume that that radius is 20 kilometers. Still we can do some kind of a boostage if the restaurant is kind of like a nearby. For example, like within 10 kilometers, we will boost those restaurants more than the restaurants which are far away. So we have done all this kind of changes in or like changes in weight and boost factors. One problem here is like, how do you know which weight will work for us, right? This is where we need to do kind of an experiments with different variants and to find out what is the ideal weight or boost values for each and every fields. Initially, we have done a very bare minimum experiment and variance with the user ID modulus based, and later we moved to a full-fledged experimentation platform which is created by our platform team. Where you can create a dynamic variants of an experiment and also promote one of the variant as a rollout release plan and all. So another one is personalization. Imagine like two users are searching for the same query, but they may be expecting a different result according to their past history. For example, like a user searching for pizza and always ordering from Pizza Hut, they will like to see Pizza Hut as the first restaurant, and maybe the other user may need to see Domino's as the first result. Also, let's say if someone is searching for chicken, for the breakfast, they may be looking for some other kind of restaurants than for dinner. So how do we track all those kind of information? So we have to add more and more factors to include this one in personalization. For example, like what are the various orders a user did in past, what time of what time they have ordered, what type of restaurant they have ordered. All these factors need to be included if you want to do this kind of personalization. Turns out that this is very difficult to do it in Elasticsearch because the number of factors are too high, and also even if you are doing it in Elasticsearch, and if you want to do this kind of tuning manually to find out which factors and which weight are better, it's humanly impossible to do it because of the number of permutation and combination is so high. So we decided to go with a machine learning model for this one, where we can do various type of models, like let's say kind of like a decision tree based model, where we can include all these factors, and the model will identify the weightage of each factor by itself. The only issue here is how do we execute this model for Elasticsearch relevance ranking. So the Elasticsearch has a plugin architecture where there is a learn to rank plugin which we can use, where we can deploy our own model into that one, and Elasticsearch will use that model for running, or like whenever there is a search happen, then it will use this model to do the ranking for us. So this changed the architecture. So you can consider there are two things there. One is like for individual search, how that is happening, and the another one is like post search, where we have to analyze the data and come up with the improvement of the system. So whenever there is a search happens, We right now has two type of Elasticsearch indexes. One is like a non-personalized index, and another one is a personalized index. We are still keeping the non-personalized index mainly because there are cases like, for example, some of the collections is not required a personalization. And another case is like some internal services called search service for some kind of result. And there the user attributes may not be there, and hence we cannot do the personalization. Um, Assume that the query is coming from an existing user, we can do the personalization so that it will use the personalization index along with the factors of the customer, like their previous orders and all, as we have mentioned in the previous slide. All these things will be used for doing the personalization. So for each search, we will generate a search log, depends on how that search behavior, and also the LTR plugin will give the score of this search depends on various factors. And we will push those data into a queue, and which will be later consumed by our data scientist team to come up with a better model or better version of the model. Now, assume that the new version of the model created, and that need to be deployed in Elasticsearch again, and we have to compare the result of the two different versions of the model to find out which one is performing better, right? Here also we have used the same experimentation platform. At a time we used to run more than 5 variants of the same experiment with different versions of the model. And sometimes the model performance will be down and sometimes up. And we add more and more factors, or sometimes we even remove some of the factors if it is not giving any improvement at all. This was working for some time, and then our volume of user volume and order volume, all those kind of things got increased, and we have seen some kind of a degradation in performance during the peak times. This is like the increase in latencies or the CPU usage of the Elasticsearch nodes are going up, and all those kind of degradation problems we have seen. It's majorly because of the number of searches are increased in the system. Also, the volume of the data, the number of merchants are also increased in the system. When we were doing the analysis, we found that even the LTR model caused a increase in the latencies, the query latencies by almost like 2x. And other improvements like fuzzy search and the query optimization what we have done, that is also caused some kind of latency increase in the system. And of course, the read and write throughput of the data also increased. So the mitigation plan is to horizontally scale the system as any other service which we do, right? So what we did is like we added more number of Elasticsearch nodes and replicas to avoid this increase in the CPU usage or query latencies. And also we added a batching while writing data to Elasticsearch, and that batching helped us to reduce the latencies, the write latencies at least. There is no Kafka lag after we have introduced batching into the system. Only concern in the batching is like we have to make sure that ordering of the messages are important, because let's say we are getting a message saying that the restaurant is closed as of now, and later point of time we are getting the same restaurant opened. And now batching, if it is doing a retry and other stuff, we have to make sure that order of messages are proper, otherwise Elasticsearch will be having a wrong information of the restaurant. Anyway, we have done all these things, and we have seen this kind of improvement in the system as shown in the slide. Before batching, there was a lot of consumer lag in the Kafka topic, and once we have done the batching, that became zero even in the peak times. So another improvement we can do is sharding, and sharding will help us to reduce the query latency, because the number of documents which we need to look will be like less compared to the earlier times. The only challenge here is we cannot do the sharding based on restaurant ID or dish ID or something like that, since we are doing a distance based query in Elasticsearch. So what we have done is, like, you can imagine something like a city-wise sharding, city ID based sharding, but in Gojek we have something called service area, which is like, you can think about something like a geofencing and have multiple service area in a city itself. So we have used that service area based sharding, and we create like multiple service areas will be there as a part of one shard itself. One like edge case which we need to handle is, like, if there is a change in the service area for a restaurant due to some manual error or anything, that duplicate need to be avoided. Like, the previous shard also will be having the same restaurant, and the new shard also will be having the same restaurant. So our batch, the data ingestion framework need to be intelligent enough to handle these situations. And also we have to avoid the hot shards. So for example, like, this restaurants in a service area is not evenly distributed. Some service area will be having huge number of restaurants, and some service area will be having less number of restaurants. Now imagine two service area which has large number of restaurants are there in the same shard, which means that will become a hot shard, and the query latencies and all those problems can still happen. So we have to make sure that the service areas are like distributed evenly in terms of the number of restaurants and all. Anyway, we have done all this kind of changes in the system, and we have seen a reduction in the latencies by 50 to 75 ms. Also, the major advantage which we got is, like, we are able to reduce the number of replicas or nodes in Elasticsearch by 1/3 without affecting any CPU or CPU usage in the system. So this scaling helped us to reduce all the latencies problems in the system, and then now we started adding new features into the system to improve this user experience. I'll go through the very high level features right now. First one is query expansion. Query expansion is to increase the surface area of search. So certain queries will match some restaurants, and also we have to consider restaurants which are relevant to that search query, even though there is no match in Elasticsearch. The one good example is, like, let's say a user is searching for coffee, and we can include espresso or cappuccino kind of documents also as a part of this search, right? So another one is spell check. From our data, we have seen there are a lot of empty search results are happening in the system. And most of these empty search results are happening because of spelling errors, which you are not able to handle by our fuzzy search logic. So we have to introduce spell check in the system, and this spell check are not like dictionary words spell check, but it need to be compared against the restaurant name, brand names, or dish names, etc. Initially, we did a heuristic model based on ngrab in Elasticsearch. That gave a good improvement in the system, and also later we moved this logic into a machine learning model based on TensorFlow. Another major improvement we have done is indent classification. At this point of time, we have different entities in the system like dish, restaurants, brands, and cuisines, right? If you know a user is searching for a specific kind of indent, then we can promote those related search results more than the other type of indent. So we have created a indent classification algorithm, and that will predict the indent of the user query. And according to the prediction score, we will sort that particular category in the search result more than the other one. Like in the screenshot, you can see that sometimes the dish indent will come in the top, and sometimes the restaurant indent will come in the search result. So all these new features change the architecture more. Initially, all these new features also as a part of the search service itself, and later we splitted it into multiple microservices, mainly because of the scaling factor. When I'm talking about scaling, it's not just the scale in terms of throughput or the volume, but it's also in terms of the team scaling. So we splitted services into three major microservices. One is query understanding, another one is a listing service, and then a core search. Query understanding service is responsible for all these new features like query expansion, indent classification, spell check, and all. And listing service is for showing the list to the user, which has filtering logic and sorting logic and all. Also, this listing service is responsible for how to present the data to the user, the view layer of the result. The core search is responsible for the core Elasticsearch queries and also the ranking of the result. We have used gRPC for communicating between core search and the query understanding and listing service. All these things, all these services are incorporated with the experimentation platform as well. Another major change we have done in the architecture is to make use of our machine learning platform. So there is a data science platform team who they created a certain framework and tools for executing machine learning models in their platform. We initially used this platform for our spell check model and indent classification model. Later, we also moved our relevance ranking model, that LTR model, which was there in the part of Elasticsearch, to this platform. And that reduced our Elasticsearch, like Elasticsearch GPU usage, and also it's made easy for our data science team to experiment with the various models more effectively without affecting the engineering team or even the services. So this is showing a user flow, right? Like from a home screen, when user click on a search bar, it will land in a pre-search screen where it will display user search history, or like the top searches in those areas, and some quick like listing options there. When a user search for something, it will show a query understanding screen where as we mentioned earlier, there are like a lot of indent classification suggestions will happen in here. And then user can select one of those results, or they can go to a much detailed listing page, and where they can do sorting or like go to multiple pages of the result and all. So what is the future of this search team? Obviously, we have to continuously improve new features in terms of user experience and also in terms of the scale. Also, what we have found out that these features we have developed, that can be reused across other products in Gojek. So we are creating a platform where we can plug in various domain-based models into the platform, and a centralized Elasticsearch cluster which can manage various other products as well. So we are on the process of creating this platform where it's kind of like a pluggable architecture, like where if you want to plug in another model into the system and all. So what are the learnings? Right? When we are developing a search system, it will never become a 100% a perfect system. So continuous improvement of these search features are more important. And also what you are going to measure to improve, that is also very important, right? Like you have to measure the right things if you want to improve something. And another learning which we got is like pairing with data science team and VA teams, that gave us more insights and also a different perspective to look into this problem. engineers used to pair with data science team, and then they learned a lot of stuff like how do we come up with a better heuristic model that can help us to migrate to a machine learning model later point of time. How do we collect more data which can improve the system, right? So also the value of platform teams, right? So in our service, the experimentation platform and machine learning platform that help us to deliver feature faster without worrying about this kind of features, because all these things are already built by the platform team. Yeah, that's all from my side. Thank you for listening to the session.